Good evening, everyone. Welcome to the EMBA TA office hour for business analytics. This is our second meeting.
Hi, there's a bunch of people that are going to be jumping on. We just had our microeconomics TA session, so.
Oh, that's cool. Did you say microeconomics?
Yeah, so everyone's going to be jumping over, so just give it a minute.
Nice. Yeah, I've taken microeconomics courses in several occasions, and I like this content. So how was the other class? Was it more or less difficult than this one?
I think it's a little more difficult right now, I think. We'll see.
Oh. Okay.
Yeah.
Was it mostly theoretical? So you need to solve problems using simultaneous equations, or does it involve lots of data analysis?
It's a lot of equations right now.
Ah, I see.
Yeah.
Well, hopefully it's useful for solving problems at work. I recall that I did use some microeconomics knowledge when making a white paper report for the company I worked with that makes consulting projects with airports. That moment they wanted to find out what's the optimal pricing strategy for parking structures at airports. And because the managers at airports usually were curious about whether it's okay to increase their parking price. And I was able to solve this problem by using microeconomics theories, especially elasticities. Maybe you have already learned that part.
We're learning that this week.
Oh, really? Okay. So it could be useful.
I'll believe you.
All right, welcome. How about the past week with business analytics? I know that the second homework will be due tonight. So how's everyone doing with the homework too?
It was a lot.
Oh, this is Heather. Okay.
Yeah, it was a lot of work.
Were you able to finish it by far?
Yep, able to finish it.
Okay, cool. How about other students? Any questions regarding homework 2?
One question here. How detailed are you going to be as far as grading whether or not you have beautiful aesthetics to the graph or whether you remove the grid lines? Because it seemed like he cares about those things, but I'm hoping that the answers are, as long as you know how to put a graph together and you're good to go.
Oh, I like this optimistic. Yes, I'm not that picky in, first of all, I'm not the TA that grades all the homework. It'll be Saleh. But we would, if I were to do it, I would use, of course, the same standard, which you will find in the published key after the due time. So to answer your question, you don't have to make all the charts perfect. However, there are elements that you do need to include in charts. And in our last meeting, I already described what those elements are. Especially you want to label your axes to make sure that it makes sense for the readers. And the data needs to be correct. If you plot series X instead of Y, but you should plot Y, then you are plotting a wrong series of data, then it'll be problematic. Otherwise, it's fine. You don't need to be that cautious in terms of what color you need to use and how many, how much, what the width would be in terms of the axis text. Those would be two details that you could work on in your real projects, but we don't really look at them in this course.
So no, right? Short answer.
Yes, I mean, short answer is no.
Thank you.
Yeah, and I hope it's safe for you. I noticed that you're still driving with your child, probably. So
I'm in an Uber. Thank you.
Oh, okay. That'd be cool. Hello, does Jose have any questions?
I do have one question. So the homework, the submittal of the homework, do you have to submit the Excel document?
No, you don't need to.
So for those questions that I was looking at, one asked for building a histogram. What do you do? You take a snapshot and put it in the document?
Good question. You don't need to take a snapshot, especially for Microsoft suites. You can actually copy and paste the whole chart from Excel to Word.
Okay, sounds good. Yeah, makes sense.
Jose, I printed mine a PDF. I don't know if you ever do that function. Select and print the PDF, and then it'll save a copy as a PDF file.
Yes, you can definitely save a copy of PDF file.
Got
And the chart would be static after you save as PDF. But if you save as Word, it's an object. And once you change anything in Excel, usually it automatically updates in the Word file as well. If you copy and paste correctly.
Sorry, let me, I just want to make sure I'm understanding correctly. So we should be putting our tables into the problems themselves as backup, even if it doesn't expressly say that. You want all of those tables?
Tables, no, except that I remember one question requested a frequency distribution table. But other than that, you don't need to copy and paste the whole Excel sheet into Word, because we already have the original data in Excel file and everyone has it. What we want to submit in your deliverables would be the charts made out of the Excel worksheet.
Okay.
Jerry, I think there was
Hello.
one question that actually,
This is Karen.
yeah, I'm
thanks
sorry,
for
yeah,
the question.
sorry. There was one question that actually asked for what was it? Actually, it was the one that on the frequency distribution. It asked for the justice stock prices. So, or calculate the relative monthly changes. So that one, the only way to put it in is to copy the Excel table. I mean, obviously we'll get it from the histogram and the pivot table, but do you want, I mean, I put in the whole, it took up 3 pages with all the table of
I
the.
see. I mean, if you have it already, then it's fine, but it's not required.
Oh, okay. So you, on that one, like questions like that, you just want the histogram and the pivot table?
Yes.
Oh, okay.
Correct.
Okay, thank you.
No problem.
Hey, Jerry, this is Irene. I had a question.
Hi,
I know,
Irina.
hi. A bunch of our, a good chunk of our homework talks about z-scores and sort of talking about what can you learn from this or what do you glean from this. I know you're not supposed to directly help us answer the homework, but I was wondering if you can maybe walk through an example of sort of like the actual calculation. I feel like I know how to do that, right? The actual calculation, but sort of then translating that, whatever number I end up with, translating that to what does that actually mean in sort of a narrative layman's perspective. Can you help kind of, I don't know, dumb that down? I feel like I'm not necessarily, I don't know if I'm getting what I'm supposed to be getting. I do the math correctly, but sort of then translating that to what does this actually mean?
Okay, a wonderful question. Thank you, Arena. I was curious whether you think it's okay for you to share with what you have, where you have this question with us, so we can have an understanding which of those questions would be a good example to work on. But I totally understand that there's one thing to make calculations correct, and it is another to be able to make qualitative statements out of it, and this can be very important, especially it's directly included in any professional reports, and usually your audience would not really read or process all the quantitative processes step by step, but they would pay particular attention to your qualitative statements. So for Arena, do you think it's okay for you to share with some of your examples so we can work from there?
Oh, yeah. I mean, I was just sort of looking at problem number 3 in the homework. So in this one, we were to calculate Z-scores for the total number of cases and deaths in the COVID-19 worksheet. And then so yes, calculating Z-scores, but then it asks us sort of what can we learn from these statistics. Part B then goes into if you were to then normalize it by dividing it by 1 million. But I just sort of want to maybe stick to how do we, what's the, I don't know, what tips would you say how to verbalize or, the qualitative analysis of once I have the Z-score, what does that mean?
Okay, wonderful. All right, let's simply work on from question 3, part A. You had an Excel sheet of the total number of cases and also the population size of 50 countries, right? And you are to calculate a Z-score of the total number of cases and the total number of deaths for each country, and what we can learn from these statistics. So first of all, if you calculated the Z-scores correctly, then you know that this Z-score is simply the original score minus the mean score divided by the standard deviation, and particularly this standard deviation should be the sample standard deviation. So after this, we know from the definition of Z-score, it's already unitless, and it's telling us how many standard deviations the original score is away from the mean score. Does this make sense? Yes. Then from this definition of the Z-score, we can simply use the Z-score to find, for example, outliers. You have learned this in some of the videos published in the modules, saying that usually we pick Z-scores higher than 3 or lower than -3 as outliers, right? And by outliers, it means that an extremely high or extremely low value. Then, for example, you probably find the largest case to have a Z-score, for example, for 6. Then you know that this case has a particularly high number of cases of COVID. So it's a good tool to make comparisons.
I see. So so by knowing the Z-score, So it's, I know it's sort of, it tracks sort of the number of standard deviations away from the mean. So that, that definition, I know what the definition is. I think I was just trying to sort of understand how to, you know, what the actual, or how to verbalize that without sort of speaking in those terms, I guess, is what I was trying to see.
Okay, good. However, you were seeking something that's not necessary. You were saying that you wanted to describe the results without referring to some terms. I understand the purpose is that we don't want to use too many jargons in writing reports. However, to describe certain statistics correctly, we do need to refer it in the correct way. And for z-score, it does mean about how many standard deviations is away from the mean. So when we describe it, if you don't want to use z-score, then you do need to describe the meaning of it using how many standard deviations it is away from the mean. So if you simply assume that your readers know what z-scores mean, you can use these statistics somewhere next to your statement saying that, for example, I find that country A has is an outlier in terms of the number of total deaths because it has an extremely large number of deaths. That's 5 standard deviations away from the mean. Then you can simply have this as the verbal description of what we can learn from the statistics.
Okay. So even if I, on the quiz at least, being able to, I mean, talking in that kind of language is probably what will be acceptable for the quiz.
Yes.
Hey, Jerry, this is Adam Tolk here. And
Hello, Adam.
Hi, nice to meet you virtually. I hear what Irene's asking, I think, and would you be okay if I try to explain it in my words a little, and then you can tell us if we're going down the right path, because I think I know what she's trying to get at.
Yes, sure. Could you give us your example?
I'm still in the process of finalizing it, but yeah, sure. Let me share my screen, and then I'll kind of talk through.
Wonderful. Hold on. Let me enable it. I think now you're able to share your screen.
Okay. Let's do desktop. Okay. Share. Oh, I may need to open my system preference. Give me 1 second. I think it's going to force me to shut and go. If it's okay, I'm just going to do it in English I can kind of read some of it, and then you can kind of tell us if that's what works, so I don't waste a bunch of my cohort's time. Is that okay?
No problem. Oh, okay.
So Irene, I think that the way that I started to answer, and to be fair, I'm just writing the words now, but when you're speaking about problem 3A, and you're asking about how to describe what we calculate in z-scores and answer in English. And so what I wrote was, based upon the z-scores for total cases and total deaths, it appears as though the US is significantly doing worse than the 50 other countries listed, to the tune of a z-score, which tells us how many standard deviations from the mean of 5.57 and 4.72 respectively. And then the only other countries that even have there's only a handful of other countries that even have a positive z-score.
Right.
And
most of them having negative.
Exactly. Conversely, Poland is showing a z-score of minus 4.92 for total deaths, which would suggest that being a resident in Poland would lead to less deaths based on the other 50 listed countries. I put companies. So when we look at these huge z-scores, and you see a positive 4.7, which is almost 5 standard deviations away from the others that are listed, and everyone else is like in that, no one's even getting really close to 1. It shows you how significant from a statistical standpoint it looks like the US is doing poorly. Jerry, is that like in the path of what you're looking for? And and I know I need to clean it up a little, but does that answer it?
Yes, perfectly. I really like your description, and it's a really strong and powerful statement.
Okay. Now,
And
thank you
it's
for
also
that.
correct.
Thank you for that. More importantly, Irene, did any of what I said make any sense as you interpret this data? Because that's really what we're trying to do, is to make sure we all walk away with a common knowledge base.
Yeah, that makes total sense. I mean, just the numbers you threw out, those are the numbers I got. I think I was sort of just struggling then, like, to kind of just define, what does that mean? But the way that you had put that, and I was curious sort of what, I guess maybe it's open-ended because it says that what can you learn from these statistics? So based on the example that you were writing, Adam, it sounded like you kind of, took it as, hey, look at US, they have, nearly 5.57 cases of standard deviations. And so I honestly didn't kind of go down that path. I was sort of trying to do it like as a whole, like, well, most of the cases are in the below zero. What does that mean? So I think I was probably just overthinking it, but it helped to kind of hear how you approached that question.
Awesome, Irene. And the last thing that I would say on that, and then I'll be quiet, is once your standard deviation starts getting significantly larger, so you start getting to 2, 3, and that's in an absolute, so -2, -3, +2, +3. You're looking at that that U-shaped curve, right?
Right.
And so you're getting now out to the extremes. So no matter, even if you answered it by using the numbers that the US had, or Poland, or not, just by having those significant extremes shows that they're either doing really good compared to the mean or really poorly compared to the mean. And then and then how you would communicate that would be the following amplifying information. And Jerry, is that correct as well?
Yes, sure. What I said earlier was focusing only on the extremes. However, some of the time we can also focus on the majority, as what Irene said earlier. It's quite fine if you, for example, in the beginning, say that the majority, or maybe 45 out of 50 countries are within 2 or 3 standard deviations away from the mean. That means the majority of 90% of all the countries in the sample had a total number of cases or to the number of deaths with a z-score of from -3 to +3. Then we can focus on extremes, those with extremely large or extremely low values of cases and deaths.
Okay, no, that makes sense. Thank you.
No problem. Well, next, I noticed that in chat, students asked about the distinction between sample and population standard deviation. We discussed about it last time as well. In case you were not here, in question 1, you're right that question 1 particularly point out that we want population standard deviation in part B. This is because the Dow Jones Industry Average is defined by 30 companies alone. So those 30 companies are the population. However, for the country's problems we worked on for COVID cases, in problem 3, we know that there are about 260 countries and regions on this planet, and the top 50 would be kind of a sample. So we don't need to use the population standard deviation here. And in fact, in most real cases, you rarely would use population standard deviation. And we usually go with the sample standard deviation by default. Thank you. How about next question? Did James have a question?
No, that was actually my exact question, because I heard you say standard deviation for the sample a couple of times for when we're talking about 3, but I think you just answered it.
Did I hear? I just want to make sure I heard correctly. So we're supposed to use population for pretty much the whole homework, correct?
No. Population standard deviation for question 1, for problem 1 in assignment 2, because the question particularly asks for you to use it that way.
I guess I think I'm sorry, the professor in his review last week had said that we were just supposed to use population because we really don't know sample yet.
Oh,
If I heard
okay.
correctly.
Yeah,
We
he
haven't
said it.
noted that. Okay,
Yeah, Jerry,
I've only used population in my whole homework.
I see.
yeah,
Yeah, I do too.
Okay.
and Jerry, he said in a lecture like 5, 6, 7 times, we're not even getting the sample yet. Use it for population. And one
Oh,
of the
I
things,
see.
and one
All
of the
right.
things I think that's important for our cohorts to know is that when you guys are using, if you use the descriptive statistics, you remember per his little thing, where he showed us how to calculate all of those formulas all at once. When Philip and I were going through yesterday, it always hard codes in the last selection that you did. So make sure that you reselect the fields that you want to run those figures on, or you're always going to get it incorrect. And if what I just said is confusing any of you, ignore it. But if you want to know more of what I'm speaking of, I'm happy to help you offline and show you what I'm talking about.
Thank you, Adam, for specifying. And yeah, so now I understand. Okay, it's totally fine. Either you used sample or population standard deviation for the first or all the questions in homework 2. And I didn't know that we haven't learned sample standard deviations by this lecture so far. But what I said earlier about the relationship between these two still hold, that in future cases, if you do any jobs or projects at work, usually you would go with the sample standard deviation thing.
Back to kind of Irene's question, would it be okay if you were talking about kind of the impact of the outliers and how they're definitely skewing what the average case is, which corresponds to the standard deviation, and versus, taking the median, which, is a little more standard. Is it okay to talk about that portion of it as well, the impact that the outliers are having on the data?
I see. Yes, sure. However, in the example we used earlier was problem 3, part A. It's out of z-scores. The median play in part C and D. So we were not using median. That's why we didn't use median in part A. However, you raised a good point that median is more robust to extreme values. That means even if we had extreme cases like US in the list of countries, the median value would usually hold relatively the same without, instead of, for example, a mean value, the average value of deaths and cases, which would be more prone to changes and extreme values.
Okay.
Yeah. However, if you wanted to describe the impact of extreme cases, for example, US in this case, on z-scores, you would have to calculate z-scores twice. One time with US considered in a sample and another time without US considered in a sample. Then you make comparisons, which complicate the case and it's not required. So for part A, you don't have to do this. However, if you're interested in seeing what the difference would be, considering an extreme case or not, then this is the way to go.
Okay, thank you.
Hello, Tilda.
Yes.
What questions do you have?
Yeah. I have a question because actually I don't understand what this score really means in terms of a population.
Mm-hmm.
What does it really mean?
Okay, sure. We kind of touched it just now when it was oh my God, I lost the track. Was it Heather or another student asked the question regarding problem 3, part A. So here, how about I simply share my screen, then you can see it, how it's calculated. As we stated using an example of problem 3, part A, a z-score is simply the difference between the original value and the mean value in the sample, then divided by the standard deviation.
Right.
And let me, oh, okay. Here we go. Are you seeing my shared screen?
Yes, I can see
Wonderful.
your screen.
So I'm on the COVID-19 worksheet, and what you have already by default is these columns, right? We have a column of country and total cases and total deaths.
Right.
And a z-score is calculated here, z-score. So for example, the z-score of the total cases for USA, as already stated by, I believe it was Adam, saying that the z-score was 5.57. It is calculated, as I said, the difference between when you click this worksheet function area, all the reference values would be included. So you can see how these numbers are calculated. So first, we take the difference between C2, that's the original value of total cases of the country USA, and it's and a value is subtracted. This value is C53, which is this value, the average number of total cases among these 50 different countries. Then this is the difference, and it becomes a numerator. Then we have a denominator here, which is the value contained in cell C55, which is this number, the standard deviation among the 50 countries in terms of the total number of the cases.
Right.
So this is the definition of the z-score, and the meaning is that it describes how many of these standard deviations is this original score away from the mean value. And it makes intuitive sense. This 5.57 means that this number, which is 60 million, right? 60 million is 5 standard deviations. A standard deviation is almost 1 million, I believe. Let's see, no, it's like 9 million. So we know that the total cases in USA is about 50 million more than the 55 million more than the average. And in terms of the standard deviation, it's about 5.5. Did this address your question?
Not, I mean, I can, I'm able to calculate the z-score. I know the formula, but what does it really mean in terms of like, what does it really mean, just to understand the meaning of the applications of it? What does it really mean? What information does it give me, say, like in this particular case?
Did it help you when I described what this 5.57 value means?
I didn't clearly understand it. If you can go over it again, please.
Okay, sure. As I said earlier, the simplest way for us to understand the meaning of a z-value is we go through its definition or the expression. And as it shows clearly here, the z-score is simply the original value, which is C2, right? Minus the mean value, which is C53. And it's this number. Sorry, I should not change this reference. And together, we divide this difference by the standard deviation. And to interpret it and to understand its meaning and to describe it verbally and qualitatively, we can simply use the what this expression suggests. It means for the country of USA, the total number of cases is 5.57 times of the standard deviations above the average. And if we wanted to understand more intuitively, we can compare these numbers. For the US, it's about 61 million, right? And the average case is about 5.5 million. And the standard deviation is about 10 million. So that we can say, compared to the average, an average country that has about 5.5 million number of 5.5 million cases, the USA instead is much higher. But by how much? We would say that the USA, which had about 61 million cases, had a total number of cases about 5.57, yes, standard deviations. A standard deviation here means about 10 million cases above or higher than the average, which is also 5.57 million.
Okay, thank you.
My pleasure. Yeah, so in this case, we can also find that in many cases, it's actually easier to understand and interpret a value or a statistic using the expression. Although in many cases, we try to avoid using complicated expressions and equations, but lots of times it might actually help us a lot to understand and interpret any values.
Hey, Jerry.
Hello, this is John.
It is. How you doing?
I'm fine. What questions may you have?
I had a question about the adjustable. You know, when you adjust the variables for population size, problem 3B, I wasn't really sure. I wasn't really following necessarily how you know, it says first divide each of the variables by the size and then calculate z-scores. Could you walk us through that a little bit?
Yeah, sure. As we intuitively would know, the adjustment would adjust for the population size, right? That means we would divide the original values in terms of total cases and total deaths by the population size. So for example, I can also do it here. Then I'm share my screen. Okay. All right. Are you able to see the Excel worksheet I'm working on?
Yes.
So in these columns, I have the adjusted scores. For example, for USA, this number would tell us how many cases there is in, I guess this is 1 million or maybe 10 million. Oh, this is actually 1 million. So this number, the adjusted total cases, is defined by the ratio between total cases and population multiplied by 1 million. It tells us the absolute number of cases within 1 million. So as if for every 1 million people in the USA, these many cases, that's about 182,000 had COVID cases. So this is what it means by an adjusted score.
I gotcha. Okay. I took a
Then,
little
yeah,
approach.
out of this, we can calculate z-score again. So remember earlier, we calculated z-score from the raw scores. And here we use we calculate z-scores out of the adjusted scores.
I got you. I didn't get that nuance about the millions. So like you're basically saying you're trying to get to a point where you're saying cases per million residents.
Yeah.
Okay. Thank you.
Yeah, I think that's what's requested in the questions. For example, in part B of problem 3, we find the question was supplied that first divide each variable by the size of population in millions, then calculate z-score.
Yeah, I guess I just took it differently. Like I thought they're all in millions, right? So I took like 60 million over 330 million and did that division, which isn't correct, I don't think. So that's why I asked the question. But in that clarification helps me understand a little better.
I see. I didn't think what you just said made any mistakes because if we divide both the total cases and the population by 1 million, then we still have the same ratio. It's just both denominator and numerator are scaled in the same way. Then it won't change a thing.
Okay.
Okay, may I ask a question, Jerry?
Sure, Tilda, right?
Yes. Now, in fact, that goes back to the question that you asked. And using the example of USA, when the cases say divided by the population to get the adjusted population, I got like a 0.1825. So in other words, we have to multiply that by a million in order to get the actual number. Because I think that's where I was getting confused because it is a decimal. It was like 0.1825 and I couldn't make meaning of it.
Okay, so if you were worried that you could make a mistake, the best way is that you can share your screen with me and I can see whether there's any errors in the Excel function definition. Otherwise, I sort of didn't have a clue why you worried about having a decimal. It's quite okay if you have any fractions or decimal when calculating for a z-score.
No, because what it's saying is that first divide each of the variables by the size of the population in millions. So when I took the 16,954 divided by the 333 million, I got a value which was about 0.182 something. Yeah. So I couldn't make meaning of that. So what do I do to those values? So you're saying that I multiply them by a million?
You could, but you don't need to.
Okay.
So let me explain. So the number you have already right now, I can actually do it from my end. So Tilda had a case in where she was not sure whether it's necessary to multiply the adjusted scores by a million or not. I think that's actually her question, part of the question. So let's go back to these adjusted scores again. So if we simply divide the total case of USA by the size of population of USA, we get this number, which is 0.18. That's actually a percentage or a fraction if we touch this button to transfer it into a percent style, we know that it tells us that 18% of people in the USA were diagnosed with COVID. Does this make sense? Any of you
Yes.
have questions regarding
Yeah,
this?
that makes sense now.
Okay. However, earlier I showed you a different value, which is this. They are
Yes.
different in terms of whether I multiplied it by 1 million or not. So when I multiplied it by 1 million, instead of a percentage, here it tells us out of 1 million people on average, there are about 182,000 people who got COVID. That's simply, it delivers the same message. Earlier we used percentage. Here we talk about the same idea using how many people got COVID out of 1 million people. A percentage can be also understood easily as how many would get COVID among 100 average people.
Okay, now, does the professor prefer decimal or percentage or the actual number like you have it
I see.
in?
Good question. The answer is it doesn't really make any difference because in this question, eventually we need to calculate a z-score, right?
Yes.
Instead of the raw score. And you can test it for yourself. For example, if we use if we adjust the original scores in terms of the number of cases in 1 million people, we calculate a z-score, for example, like this. Then we can calculate another round of z-score by transforming the original values into percentage. As what Tilda calculated earlier, we simply divide the total case by population and get a fraction or a percentage. And we calculate z-score again. Yeah, but you'll find that both series or both columns of the scores are identical. And this is part of the property of these scores. It's not sensitive to the unit of measures. So the answer is whether you used percentage for the adjusted scores or the number of cases in 1 million population for the adjusted score. Both would get you the same set of z-scores.
Okay, thank you.
Yeah, if you had a doubt, then you can calculate for yourself to see if it's the case and why. Did any other students have questions regarding homework 2 or maybe even homework 3?
I think. I'm just wondering where I went wrong in my calculations because I'm not getting the same z-score, say for the US with raw cases. And
so for Tilda, do you mind sharing your screen with us so I can point out?
If I can, no, I don't know how to share my screen. How do I do that? Could you? Oh, okay. How do I do that to share my screen?
There's a button saying share screen at the bottom of this Zoom application.
Okay, I was actually working from a different, I had my work on a different computer. I opened up Zoom on a different computer from.
Then you can maybe open Excel in the same computer where you use this Zoom. Will that work?
Yes, let me try that.
Okay. Meanwhile, we can test it, and possibly if other students have questions, we can proceed from there. Yeah, some other students
Jerry?
try to. Oh, hi, Karen.
Hi. I'm having trouble getting the data, the analysis pack on, I think it's called the analysis pack on my Excel.
Mhm.
I went through the instructions from the video, but like when I
But I'm
click
trying
on
to
it, it doesn't come up.
see if I can.
Is that, you have to do that on every Excel sheet you open up, or once you install it in your laptop, it should be there?
It should be there all the time. Just follow the instruction in the video. And it might be a problem in terms of whether you used Excel on the web application or on a desktop application.
What was the first thing you said? What application?
Web application. If you open the Excel on the web page.
Oh,
Yeah, so there are different versions of Excel. Some have this function, some may not have it, and usually the web application have limited functions. So you usually work on the desktop and local copy of Excel.
so basically download the copy to Excel, right? To the Excel app.
Yes, you should have Office 365. It's part of the student edition that you can use for free.
Okay, thank you.
All right, Judah, have you been able to find how to share the screen of the Excel you have been working on? And how about other students? Any questions about homework 2 or 3?
If we haven't gotten to 3 and we have questions later, we can just send you an email.
Yes, you may. However, keep in mind that the homework is due tonight, right?
Is that 3? This is 2. You said 3, homework 3.
Oh, yes. We will have another meeting next Monday regarding homework 3. In case you have already started working on it, then we can also discuss them here. Thank you, Shante. I hope I pronounced your name correctly.
That is correct. No, I have not started 3 yet. Just
Not a
focusing.
problem.
Yeah, I was focusing on, I submitted 2 already.
Nice. All right, Tilda, if you still have problems regarding Excel, feel free to email me with the Excel file. You are muted at this moment in case you were trying to speak up.
Yeah, I was trying to email it to myself to email the document and be able to open the email to which I sent it, but I am not able to get, I'm not able to email it. I mean, it's not, I'm not able to get into the email because, to open the email because.
Ah, I see.
Right.
Well, if you needed to have some extra time, you could consider emailing me your Excel with your question. Then we can start from there. However, I think homework 2 is due tonight. So.
Right. Can you share again your the file for the answers? I mean, because the ones that you have, at least I can try and work through it by just looking at my own values and see if I had like one, why are my answers different from yours? I mean, from the ones that you have.
Well, the Excel file I used to illustrate and show the examples have the exact answers. So it won't be okay if I share it now.
No, I'm just.
But feel free to share with me your Excel file. Then I can possibly detect whether there are any errors in it.
Okay, I will do that. And
yeah. And make sure you include your questions regarding which part you found problematic, so I can look into it.
Okay.
Wonderful. I hope I can solve your problem before the due time. And how about other students? Any questions from Philip and Donald and Ahmed? Since you haven't spoken so far, I would assume you are able to solve all the problems, and let me know in case you need extra help.
Very quickly, your email is J.
Oh, right. And let me simply type it in the chat room. So you can see it.
J-I-A-R-U-I.
Yeah, you can also find it on Canvas. And for the students, have a great night.
Thanks, Jerry. Have a good one.
No problem. You too.
Thank you, Jerry. I'm going to email it to you right now because I'm going to email it to you right now. Then again, it will be like by looking at what I have, why do I have those different scores? Where did I go wrong in the calculations?
Mm-hmm. Sure.
Thank you.
Then I look forward to your email.
Right. I'm just going to email it to you right now. Oh, yeah.
Do you want me to stay in the meeting?
Yeah. Yes. I was. If you could, please, Jerry, I will appreciate it because I don't get things as quickly as my colleagues, my classmates, and so it is JIARUIT at uci.edu. Okay, and then where's the attachment? Attach problem to tilde. Attach copy. And send. Don't want to send. I've sent it to you without actually putting a message. I've just sent it.
Okay. Then how about I share the screen of your Excel file? Then you can tell me where you had the problems.
Okay.
Probably take a few seconds for me to receive it. Okay, you just got your file. All right, let me share the screen with you. Then this is the Excel worksheet you have been working on. And,
Yes, this is the
could
Excel
you
worksheet I was
please
working on.
point out where you had questions?
Right. Now, this, I mean, if I can point out what I did, and then you can say whether what I did was right or wrong. I mean, in other words, I can explain to you what I did. So what I did was to calculate the z-score. I first of all calculated the mean of this column here.
Yeah, it looks correct.
Okay, and then calculated the mean and standard deviation of here, but I also calculated the mean and standard deviation of everything. So I've got the mean for each of those columns, right? And then I used the formula, which is this value, for the z-score, for the cases, I use this value divided by the mean of this value. So, and then divided it by the standard deviation. So everything in the same column is what I use to find the z-score. And so I got that, I got this.
Yeah, so far all these columns look correct.
Okay.
Yeah. So which of these did you had any concerns?
No, because you say that, I mean, when you're answering question number, if the columns are all correct, so, but I heard, if I heard you correctly, you said, that question which says, what can you learn from these statistics and how that they different from the ones you calculated in part A, which one make more sense? And if I heard you correctly, you said that the score that I got in, if I can go back, can you go back to my screen? You said that the score that I got here should be the same score as I get here, but it is not the same.
Which scores are you referring to?
Sorry, I'm looking at question 3. Now, this one, I mean, this column here, the one I'm pointing to under column K.
Oh, sorry. Yeah, I cannot see which column you're pointing to. You need to let me know.
Okay, I'm looking at column K. That one, column K. That is this score that I calculated. I used the population. I think I used the population, this score.
Yeah,
Uh,
column K is the z-score of population, which is not really asked in any questions. So, but you calculate
yes,
it, but
it's not
fine.
fast, but I did calculate it.
Mhm.
Okay. But then you said that I should expect that the z-score of this should be the same as the z-score of that. And I don't see how the difference, I cannot make any sense out of the z-score,
Oh,
whether
okay.
I'm using the adjusted or this particular z-score. I don't see, they're not the same.
Mhm. Which of the z-scores are you comparing?
I'm comparing column G and
G?
column
Oh,
Q.
G, column Q.
G and Q.
Yeah, so those are different because they are calculated either not adjusted and adjusted adjusted cases. However, the statement I made are about two ways of making the adjustments. So by the two ways, they are the same. So you could calculate another adjusted score, not in this way, but in a different way. For example, the different way means that, for example, if I changed, see that I'm changing your definition, okay? So if we add 1 million, this is 3, okay, this is 1 million. Then I changed the way we adjust the scores, right? And you find that the values are different. However, the z-scores stay the same. It's still 1.20. If we do it again, here, notice that before any changes, this is 0.77, right? And if we do the same, multiply this by 1 million, and you need to fill it through all the cells for 50 cases. You find that the z-score stays the same. That's what I meant. Either you use the adjusted cases by a percentage, which is this much, right? And you could possibly change the format into percentage. Or
Yeah, I think the percentage, yes, okay.
yeah, or you use the absolute number within 1 million population, how many would get infected, how many would died out of COVID. This is what this
Right.
column means, right? Notice that the numbers are much larger than 100%, it's like thousands. And the z-scores would be the same as if it was calculated from percentage. That's what I meant. There are, no matter which way you adjust
Whether you
the
use
score.
Okay, whether I use percentage or not, it would make no difference.
Yeah. So you can test it yourself to see whether it is the case and why it should be the case.
Okay.
Wonderful. You calculated all the columns correct, and looks great.
Oh, wonderful. I am struggling. I stay up like, I mean, this just doing this part has taken me like 3 hours.
I see. Yeah, so were you able to get through all the videos by the professor?
Yes, I went through the videos.
Then it should include many examples, and it should help you understand what to do in each step.
Okay, yes. It takes me more time.
I see. Probably it's your among your first times to use Excel as frequently.
Yes, I did some Excel MBA math. I actually even bought a book.
I see.
I even got this.
I remember I point you to the files the professor shared with us in the Google Drive, right? Did you get them?
No.
Last time when you asked about how to use Excel, I particularly point out to the Google Doc and files. Here you find the Google Drive link where you can find Excel bootcamp file. This is a very thorough book the professor prepared for most useful functions and applications with Excel. So
if I go to Google Doc files,
yeah, you can simply go to Canvas and use the resources here.
okay.
Yeah, this might be easier than a physical book, especially if you want to make searches. So you know that in PDF, you can search by keywords.
Okay, let me see if I can get to that. Google Files.
It's on Canvas. Then you can find the link or the tab saying Google Docs and
Then
Files.
open new tab, but this says open new tab.
Yeah, you can find lots of resources there.
Excel files. Oh yeah. Okay,
This
so
has been pointed out in previous handouts and Canvas slides. So make sure you don't miss some of the Canvas content already.
okay, but which one? Can you open back into? Oh, okay, it is this one. Okay.
Yeah, I'm still sharing the screen, and you can see that there are two PDF files. You should usually go to this Excel for Business Analytics.
Right.
And if you, for example, if you want to cover this one, it doesn't have it, but you can use the function. Yeah, so for example, you could go to this second section about formula and functions and understand what functions and formulas means in Excel. Then you can go to, for example, page 47. Then you can see all the content, how we can use Excel functions.
Okay.
Yeah, here, for example, explains clearly what functions are and where to start and how to pay attention to the relative and absolute reference of cells, which you did great. In your example here, this would be called relative reference, and these with dollar signs would be called absolute relevance. See that
Right.
with each move of the cell position, the value of C53 and C54 stays the same.
Right.
Yeah, but the C3 would be different. So you did great.
Oh, thank you so much. Thank you.
Yeah, and I also like how you formulated all the cell values so that they look very clear and concise.
Thank you.
Yeah, and you also formulated the negative numbers to highlight them. So it's also a good practice. So you are, yeah, you have been doing great in these. So I'm really glad that although it took some longer time than what you expected, but you got both corrected and also great results.
Oh, thank you so much. I appreciate that. At least that makes me feel really good. Thank you.
Yeah, no problem. I hope you enjoy
and you should be getting, you'll definitely get it before midnight.
Great. I look forward to it.
All right, thank you.
All right, Yoda.
All right, now, if I may ask again, regarding I think it is the language that is a problem for me in terms of like, in terms of like the meaning, I probably need to find like, oh yeah, going back to question number 2, for the frequency distribution, okay, does the professor want like a table? Do you want like a table?
Yeah, a frequency distribution is usually refers to a table.
A table, right. Okay, because those are like the word distribution, now table, so that's where the confusion was for me. If I go back to that question 2.
Yeah, but I'm glad you got the answer correct.
The answer for,
I mean, frequency means table here,
Oh, okay.
or distribution.
right. That Zisco, the meaning of Zisco is still bothering me.
Oh, okay.
I really don't understand what it really means. That is the problem that I have. I Googled the meaning of Zisco, and I couldn't understand. It was actually gave us a graph, but I couldn't get it.
All right. We already demonstrated this example earlier, but to summarize it in one sentence, this means the score. This score is the number of standard deviations by which the value of a raw score is above or below the mean value of what is being observed or measured. This is what you can find on Wikipedia. I believe you can find something similar in the handout and videos of Canvas.
Right.
Yeah.
And then let me go back to getting it from you, making sure that I understood what it says. And standard deviation is like, say, if this is the mean, all right, say if the middle is the mean, whatever is below on the right, the positive side of that standard deviation.
So to help you understand what a standard deviation is, you can also find the definition of a standard deviation. However, intuitively, it's the average distance between each pair of scores in the series of values. So, for example, if we go back to what we had earlier, out of the raw score here, right? We calculate this. These scores, and these scores were based on standard deviations as well. So if you wondered what standard deviation here means, it's actually the distance between each pair, each possible pair of them. That's the average distance between pairs of observations in these series.
Between observations.
Yeah, an observation is like a value. So here we have 50 countries and each of them is an observation. So we say that we have 50 observations.
Okay. And the distance between each observation.
Yeah. So distance means like how much difference they are. For example, a distance between USA and India is about, let's say 25 million. You can see that, right?
Right, yes.
Yeah, so this is a distance. It also means a difference. If we plotted on a plot like this one, then we can know that each of the value falls, for example, here and here and here, then there's a distance between them, right? If we go over all possible pairs of the distance, then the average distance can be understood as the standard deviation. Standard
Okay.
deviation is basically how much spread it is. As it shows here, the definition is that the standard deviation is a measure of the amount of variation or dispersion of a set of values.
Values.
Yeah, so the dispersion is that how wide this shape is. And if there's a comparison, well, there are no other about standard deviation. Let me find an image so we can see. Okay, yeah, this is the kind of image I was looking for. From this, we can know that yeah, now we can do it. So from this, these are 3 different standard deviations. The blue one means a standard deviation of 5, red one 10, and the green one 20. And you see that for standard deviation equal to 5, it's very thin, right?
Yes, they're very close together.
Yeah. So
And-
that's what it means by it's not dispersed that much.
Right.
That's what dispersed means. Or
Okay.
variation. It doesn't vary that much. However, if we go to standard deviation equal to 20, the green line, we see that it's really bad. It's spread out.
Right.
So that's what an intuitive sense of standard deviation is. And
Right.
a z-score is describing the raw value in terms of standard deviation. Yeah, it's just how much standard deviation, how many standard deviations a raw score is away from the mean value.
How many standard deviations?
Yeah, you can find these in on Wikipedia, and it gives you examples. For example, here it gives you the equation of z-score, and
Right.
you can also apply them in different cases.
Okay. All right. I will try to explain it as best as I understand it from your explanation, and I'm hoping that it will make sense to you.
Sure, I'm sure it will be.
Thank you very much, Jerry.
No problem.
And have a good night.
You too.
Thank
Bye-bye.
you. Bye-bye.